Hello everyone, good morning. Today I am going to present one of the most intriguing unsolved problems in mathematics, the 3n plus 1 problem, also known as the Collatz conjecture. Though it sounds simple, it has deep mathematical mysteries. Let's dive in. Dive in. Introduction to the 3n plus 1 problem. The 3n plus 1 problem was proposed by German mathematician Lothar Collatz in 1937. It's famous for being easy to understand but incredibly difficult to solve. Despite decades of, of study, no one has proven whether the conjecture is true for all positive integers. The problem statement. Here's how it works. Starts with any positive integer. If the number is even, if the number is even, divide it by 2. If the number is odd, multiply by 3 plus and add 1. Then repeat this process. The Collatz conjecture states that no matter what number you start with, you'll eventually reach 1. Next, example of 3n plus 1 process. Let's take an example starting with 6. We get the sequence. 6 is a positive number and even also. Then divide it by 2, it gives 3. Then 3 is odd number. Then multiply by 3, add 1. It gives 10. This process continues until the given answer loop is given answer is 1. End answer is 1. This is the cyclic process. It enters in a loop which is 4 2 1. This shows how even a small number can generate a su- surprisingly long sequence. Key characteristics. What makes this conjecture fascinating is that it applies to all positive integers. No, no number tested so far has failed to reach 1, even up to numbers below 2 raised to 60. 8, 8 no one has been able to prove this holds true for even every possible number. Why it is important. This problem shows how simple rules can create very complex behavior. It's connected to number theory, chaos theory, and computational mathematics. It is also demonstrates the limitations of current mathematical tools when dealing with unpredictability. Next, current status of the problem. Despite being studied for over 80 years, the Collatz conjecture is still an open problem. No one has found no one has found a proof or a counter example. Mathematicians consider it deceptively simple, the kind of problem that looks solvable but might take decades or even centuries. Next, example, ec- applications and implications. Beyond pure mathematics, the Collatz conjecture is used to teach recursion and algorithm thinking. Sorry, algorithm thinking. It's also linked to discrete dynamically systems where simple steps generate complex behavior. It helps students understand how iterative processes works. Challenges in solving the 3n plus 1 problem. Highly irregular and unpredictable sequence. Lack of clear mathematical structure. The main challenge lies in the unpredictable nature of the sequences. They seem to have no regular pattern or structure, make it hard to analyze them mathematically. Many believe that solving this problem might require entirely new methods in number theory. Conclusion. In conclusion, the 3n plus 1 problem is a beautifully simple yet deeply mysterious puzzle. It continues to fascinate both professional and immature mathematicians and reminds us that even the most basic question can lead up profound discoveries. This is all about the 3n plus 1 problem, and now we will solve a problem on this in Python language. This is the problem I have created here, and we will run this. Here it is showing enter a positive number. I'll give 55. And this is the Collatz sequence, and the total steps are 1 and 12. 1 and 12. This is the output of this whole code, Python language, in Python language. And thank you for listening me.